Guys.
Good evening, Anil.
Good evening. Okay, so last 2 weeks back, we introduced Docker. I hope you all guys have started working on Docker, played with Docker commands, right? So in your systems, you might have installed Docker, right? And also, I remember we had introduced with AWS, creating AWS account and working on AWS services, right? So probably I hope everybody is having or having their AWS account, right? So we will, if possible, like if everybody has their AWS account, we can actually run few of the services today live. Along with me, you can also try running those services and how to run Docker on AWS services and all those things we can actually run. So Docker, we introduced Docker, right? What is Docker? What is Docker Hub? Basically, we also have mentioned that Docker is a container management tool. So we can manage multiple containers using Docker, and we can actually create our own images. We can pull existing images from something called Docker Hub, which is a container registry. So we'll learn about how to pull Docker images from Docker Hub, how to create a container from the pulled images, uh, and how to map the ports of the Docker to the local machine in our local machine. We also discussed about the architecture of Docker, how the Docker runs. So I just wanted to give a brief of what we have done last, and today's session also we will continue with Docker. We will learn more and more about Docker. Okay, so yeah, let me open the last sessions. This is what we have learned in the last session. So I hope you have created your AWS account there. So how to install Docker, quick way. Also, we had introduction of what is Docker desktop. Docker desktop, we learned about, and also we came across brief about, we had conclusion that next session we'll be learning about Docker files. So those things we'll learn, that's what we learned, right? So today we'll continue the Docker session. So let's wait for some time so that few other people will join now. Okay, we have few more people joining. Yeah, so let me open my AWS account also. So I want to recollect what we had done in the last session. So we created a AWS account. If we don't have AWS account, we can actually sign up for the AWS account. It will ask for basic information, and just for the record purpose, they will ask for credit card information, but it will not be charged. Okay, so yeah, so last time I think we saw how to create EC2 instances, in AWS. Today we learn few more services of AWS and how to use how AWS we can use services, we can use and learn about continuous integration and continuous deployment using Docker and AWS and other tools together. Okay.
Anil, are you sharing the screen?
No, actually, yeah, I have to share something. Okay. Uh, okay. Okay. So last time we created a EC2 instances, right? We say we created a EC2 instance, and there um, we have created a basic core machine in EC2 instances, and seen how we can create and how we can delete and all those things, right? So today we will actually learn about a few more other concepts of Docker. So we will start with the basic commands, like open we can open the Docker desktop to make sure that our Docker is running now. So this is Docker desktop. So if you are able to open the Docker desktop, that means your Docker is running. So then you can actually um, run the Docker commands in your terminal. So these are the commands. We know the basic. We know all the mostly we covered mostly used commands. Pull, push, Docker PS, Docker images, Docker remove images. All those we actually learned about how to use them. RMI. So today we learn about Docker build, Docker commit, Docker push. So basically, we already know that Docker has its own container registry. There is something called container registry we learned in the last session about container registry. What is a Docker container registry? Which is called Docker Hub. So Docker provides free pulling and pushing into images into Docker Hub. You can create your own Docker Hub account. So let's go to Docker Hub. So this is what is container registry for Docker. So here you can see that I already have a repository under Anil Bhat account. I have few repositories here I have created. I can actually manually delete also by going there and delete the repositories. Um, you have to type to confirm that you want to delete.
So it is similar like GitHub.
Yeah, so GitHub actually stores the code. It stores the code, right? Whatever code you write, but here it stores the images. This is actually image. So it is a running application. Like it is, for example, this is a Postgres application. You just need to download this particular image, and then you can actually run that image to run a Postgres instance. So if you remember, Docker is all about containers, right? So containers and images. So we can actually imagine that. So we have a running container at any point of time. You can actually start that container. You can stop the container. That container itself has an application in running inside. So if you remember the diagram of this diagram, right? This diagram, if you remember, in the middle, right? This is what the Docker architecture looks like. Container architecture looks like. So in the top, you can see that app A, app B, app C, right? So they are applications. So applications can be web applications, can be a database application, or any kind of application, right? So this app is running as a container that runs as a container. This container, you can actually, the static version of the container, which is called image of a, you can actually upload it to a container registry, which is called Docker Hub in case of Docker. So in market, there are many container registry. Docker has its own container registry, which is called Docker Hub. You can store your application images. You can store your application images from in Docker Hub. So in this case, for example, I have two images which I stored in Docker Hub in my repository. So Docker Hub provides a free account where you can actually store your own images. So images are nothing but the running applications, instance, not instance. It's like um, image is nothing but the the snapshot of the applications which you can actually pull again and start it again. So that is what is we are storing. Like for example, here you are having this application, right? You can actually pull it from the Docker Hub again by running the command. So by running the command, uh, git
Anil,
pull.
we have Azure, let's say Azure VM. So when we are using the Azure VM in Azure portal, so we
Mhm.
can create an image of that VM for the backup. So like that, it mean by that for this document.
No, actually, in the VM, you can actually run a Docker instance. VM can be looked as your laptop only. So your laptop has your operating system, something like you might be running on a Windows machine, right, in your laptop.
Correct.
So
So
yeah,
all the backups we can take it as a image, correct?
no, it's not VM backup.
No,
So
for like that I'm asking. Like that it will be like this. I mean,
it is.
where we store the image in Docker Hub, correct? No.
So here you can see that it's the same like Azure VM only, but there is no operating system in that particular backup. The backup,
Okay,
whatever you take, the backup doesn't contain the entire operating system. So it contains only the applications that you want to deploy, not the operating system. So here in this example, right, in the middle, you see VM basically means it contains the entire operating system here. In the right side, you can see it is the
yeah,
VM. So it contains OS also. But in the middle, you can see that OS is different. It is running separately. In the top of the OS, you are running different applications. So it is a very lighter version, what you can say. It is very lighter version without any OS. It contains only the running applications instances or specific which are which are running over the operating system. So those are called images. So imagine that in Azure we have a VM, you have a VM, and in that VM you are running particular node.js Docker container. You are running a node.js application. You can run a node.js. So you are a C# developer, right? So you can run a C# application directly in your Azure VM, for example, right? Instead of running
okay,
instead of running the C# application, whether it is a desktop application, whether it is a C# based ASP.NET web application. So instead of running directly into the VM, you actually create a sandboxed environment called container. Inside that container, you are running the C# application. So that container can be looked at as a separate box, which can be ported, which can be copied and which is very portable enough, which can be copied to any other VM also. So it is as simple as just copying that particular container to another machine. So you just need to store that particular in some content registry, common repository, and you have to again pull it back to another VM. So it can be easily moved from one virtual machine to another virtual machine, just like that. So I will just show you. So here, for example, here you have a Postgres application. Like I said, C# application. Here I have a crunchy Postgres application. I can just pull this particular image. So I can just go. So this is the command to actually pull the Postgres instance. Mm. So it is to push. Similarly, I can actually pull. So I can just say Docker pull. Docker pull by default it will be Anil but B only because I'm connected to Anil but B, or I can just type crunchy progress.gs. This is the image name which is already there in Docker Hub. I am just pulling that image into my local machine. So by doing this command, by executing this command, it is trying to look. I am not connected. Okay. So let me see the what is the version. Not for 5 months. Uh, yeah, so this is what crunchy represent. Yeah, Anil Bhat B slash crunchy PostgreSQL, right? Yeah. Am I logged in is the question. So I can actually log into Docker Hub by using a Docker login. Login succeeded. Login is there. Okay, I don't have any images here, I think so, right? So let me go to other repositories. Yeah, these are all old. Okay, I have one tag called latest here. So this is the repository I have. In that, I didn't have any repository. So let me push this. So I can say Docker pull and this. Okay. Mm-hmm. Okay, it is taking some time. Am I connected to? Okay. Well, Docker pull, right? Yeah, this repository is there. So I think I have some access rights. Latest Docker pull. Yeah, I logged in. I am logging. I don't know why didn't work. It should have worked before also. So right now I am pulling the repository. Docker. This Docker 101 tutorial is the image. I am just pulling this. I am successfully able to pull it. Now let me check why I was not able to pull the previous version. Docker 101 tutorial. I added the tag. Without tag also it should be able to pull. Let me check again. So you understood, right? So yeah, now it worked. So sometimes because of network connectivity, it is not able to pull. Now it is able to it is trying to pull and it identified that it is already pulled. So you are actually pulling this particular repository from Docker Hub, from the Docker Hub to a local machine. And you can check that that particular repository is that particular image is already there by connecting to by typing the command docker images. So here in the list of all images, you can actually see that particular repository. Docker 101 tutorial. So this is what the repository you just downloaded by using the pull command. Now you can run this particular repository, this particular Docker container. Imagine this is a application. Now you can run this particular image by executing the command docker run and that particular repository. I think it should work without Anil but B also. No, it actually works only with account. So generally you can create repository without account name, but Docker Hub expects the account name as part of the Docker images name. We should give the account name also when it comes to Docker Hub. Now you can see that you have started running a nginx instance. I think it should work in localhost. Localhost with I don't remember the port. I can actually build a separate instance, but you can see that the application is running. We need to identify which port it is running. Probably default is 8080. It's working fine. No, it is not the port. This is the Jenkins instance. Okay. Mm, okay. So yeah, so let me explain you again. So I had this particular Docker image. This Docker image can be identified. You can push the Docker image by this particular command, Docker push, and you can actually pull the image from your local machine, from your repository to your local machine by executing the command Docker pull. So once you pull the images, you can actually see the image available by running the command docker images. By running the docker images, you can see that, right? And if you don't want it, you can actually delete the image by executing the command docker rmi. And okay, so in order to delete it, you have to stop the container. So you have to stop that container by looking into the container name. The container name you can identify. So you can see that I have lot of containers already in this list in my machine. In my local machine, I have this many containers. You can see that there is a container. This is the latest container that I have created. Other than that, I have few other containers. My first app web. There is some other container called key clock. There is a Apache container. There is other container Bitnappy, nginx. Bitnappy, I think this container I created long back when I actually gave the Python demo to you only. So you must be also be having it if you have tried it out. So there is Prometheus container, Apache AP6 dashboard container, Grafana. So there are a lot of containers actually running. You can see that like this, and you can see that to which ports they are actually exposed to. Few don't have any default ports, so I am not able to identify which port I have connected to. But there may be that if I explicitly mention that, I can actually say like this particular thing, right? You can say that there is an instance key clock container called key clock, which is running in container 8081. So let me try. So if I can show you this container is Jenkins container, which is running in 8080 port. And there is another container 8081, right? 81. Okay, this does not running. Okay. 8081. Okay, it is in exited mode. Maybe I can start it again and then it will run. So here you can see that Jenkins is running an 8080 port, right? Here, by doing the Docker in this particular list, you can see which port is 8080. Here you can see in the bottom, you have a Jenkins instance with this particular ID, 8FB, right? So this one you can actually you can see that this is Jenkins. I will teach about Jenkins in the probably next session. So I can run my own Docker application, Jenkins Docker application. So here now I am running a Jenkins Docker application, which is running under port 8080. So I am able to see the Jenkins dashboard here. If I remember the password, okay, I remember the password. So I entered into the Jenkins dashboard here. You can see this. So it is this Jenkins application is running in under port 8080. So let stop this particular Docker instance, which is running under 8080. So you can see this Docker is having instance. This is the container ID, right? So I can just stop this now. So to stop it, I can just say Docker stop and the container ID. Once I say stop the container ID, it will just stop the container. Now, if I actually run this port again, you can see that it is not accessible because I stopped the container. Again, I can actually start the container by saying Docker start and the container name. Probably it will run on the same port. So now I will actually see Docker PS. I can run Docker PS command. Now I can see that again the dashboard is up. So I actually started the Docker by executing Docker start and the container name, right? Now by running this, I can see that Jenkins is running again. Now let's see another instance. I was looking for a container with port number 8081. It is not running, right? This is not running. 8081 is not running. So here you can see the there is a container which is running one particular application called key clock, and it is supposed to run on the 8080, but its status is exited. It is exited means it is not running anymore. So you want to start it, right? So you can just say Docker start, and this is the container ID. So you go to this, you copy this, and again you run this Docker start, and the container ID, and hopefully it successfully got started. So again, you can verify it by typing Docker PS. It will list all the running containers. Now let's look into this container we are trying to start, right? This is running under 8081 port. So you already started it. You can verify it now here. Localhost 8081. It was not running before. Now I'll run again. Now you can see that there is some application running, right? So similarly, if you want to create your own application, we can create our own applications also. I have created in the same machine, I have created one application called Jenkins. I have run the Jenkins application under port 8080. I have run Keycloak application under port 8081. So similarly, let's say if I don't remember I don't remember what is this particular Docker 101 tutorial, but we can try starting this particular image Anil but Docker 1 tutorial with exposing it in one particular port. I'm not sure. We can run it by, there is a command called -p, which says which port you need to expose it. So I'm not sure whether it is a web application. If it is a web application, and if I expose in one particular port, it should actually run. It should run. Let me try that. So let me delete this particular application for now. This is the container ID which is executed. So Docker stop. Let me stop it. I stopped it, and again I will run Docker run. Docker first. Let me remove the image. You can see the list of all images using Docker images, and here you want to delete what you have downloaded right now. You remember you downloaded a particular instance called Docker 101 tutorial from Docker Hub, right? This is what you actually downloaded it, right? So that image is available here. Anil but B Docker 101 tutorial, right? This image, right? So if you want, you can actually delete it. You can delete it. Docker by using Docker RMI and this particular image. You can delete it. Okay, so Docker container will be deleted. Docker container. Okay, Docker container is already deleted. Okay, Docker container which is not running. Docker PS -a lists all containers. Docker PS actually lists only running containers. PS -a lists you all containers. So here you can see this container is already there. So you have to delete this container. So to delete the container, you have to say remove the container docker rm and the container ID, and you remove the container. Now you can actually delete the images also. So to delete the images, you have to find out the image ID. So here in this particular list, you can get the Docker image ID by looking into this one, right? So this one is the image. You can actually directly give the image ID like this. Um, so you can actually delete like this Docker and image ID, and you have deleted it. Now you can check that whether the image is there or not by typing Docker images. Now you can see that that image is not there at all, right? So this is how Docker commands actually you can use to run, stop, delete a particular image and container, right? So we will go to the next topic now. So today we try to run a particular sample application, and today we learn about how to create your own application. So for that, just go, we have already created a repository, a sample repository, a simple application. We have a simple HTML application we have created, and we can use that particular application. It is there in our in our course. The GitHub link is there in our course. You can just go to that particular GitHub repository and download or fork it by yourself. So that you can do it. Go to the go to our courses, go to my courses, and here here in your courses you can actually go to this particular course topic number 10. Here you can see a repository, right? So there is a repository already created which will give you demo of how to create your own Docker instance. You can just clone this particular repository. So here you can see that it is a simple HTML application. You can do your any application of your own. So for C# guys, you can write your own C# code in your GitHub repository and create your own Docker container, and try to run the Docker container application inside the Docker container. For our demo purpose, we are using a simple HTML application, which contains only two HTML pages, and we want to deploy it inside the Docker, not in the machine. So in order to create your own Docker container which with the application inside it, you can actually create using a command called docker build. So that's what we will try to do now. I have forked this repository within my personal repository, so I will use that. Both contains the same code. I'll just use mine. So now I'm going there. Now this is my first repository, and it contains the same code. It contains HTML code, days.html and index.html. We are going to clone this. We are going to clone this repository now. Now let's make sure that we don't have that repository here. My first tab is there, so let me delete it. So to delete it, I did -rf. Oh, I don't have that repository. Now to clone this particular repository, I go to this repository, copy this code. You can either use HTTPS to clone or SSH to clone. Okay, so today we don't have Rick. Okay, so so we will actually clone this repository. Just it is a public repository. Just copy this particular repository URL and try to clone it. So just clone this particular repository now. Now our repository is very just got cloned. You can go to the repository by typing the repository name, my first app. Now you can see that you have the code available. This is the code that you have, right? So we have some hidden files also. Today we are going to learn about a circle CI/CD tool called Travis. We will learn about Travis also. So as long as we have time, we'll cover as much as possible. Okay. Now now let's see what can we do with this particular repository. So this repository is a very simple repository. So it contains HTML, few only two HTML pages. We want to run this particular HTML page, right? So you can just you can run this particular application inside your machine. Also, you can just go to this machine, and you can just double click on the HTML page, right? My first app. HTML, and you can just go, right? So you can just run this application by going to the file. Now this particular HTML is very simple. It has got a link to go to dev's page. One click on the dev page, you will go to a weekly days page, which displays the days in different colors for Saturday, Sunday, and normal style for other days, right? So weekends and weekdays, that's what we are going to display. That you can see in the code. It is a simple days HTML with list of elements, and Saturday and Sunday are having a different style. Active actually, if you say active, that means it is coming with different style. That's it. So this is a simple application. Now we will see how we are going to build this application as a Docker container. How will we do that? To do that, what we need to do is, like, first we need to create a file called Docker file. Okay, so you can see that we can see the Docker. Let me open in Visual Studio. I'll open the repository in Visual Studio. So this is my first app. I'll just open the repository in Visual Studio. Now you can see our HTML pages. These are our HTML pages. Index.html, days.html. Now we want to deploy it as a web server, right? So for that, we need to create a simple file called Docker file. So Docker file is nothing but a simple text file, and this is what it looks like capital DOCKER file. So this is the file that you are supposed to just create. So Docker file is well understood by the Docker CLI command tool. So if you run Docker build, then it will automatically run whatever you have written in this particular file, Docker file. So now we are going to understand how to write a Docker file. So go to this particular Docker file, and you can see this is the commands that we have already written in Docker file. So let's try to understand what this command actually means. So this means, like, from nginx, from nginx. So every Docker container actually starts from one particular base image. So here in this case, nginx is one image, and this particular nginx should already. So when you say from nginx, this nginx is actually downloaded from Docker Hub. So in Docker Hub, there should be a image called nginx. Okay, so you can just go to the repository, search for nginx here in Docker Hub. You go to dockerhub.com and search for nginx. Now you can see that there is a repository called nginx, which is official build of nginx company. Now it is open source, and you can actually download this particular nginx by doing a docker pull nginx. Okay, so by doing docker pull nginx, it will download it from your machine, from the Docker Hub to your local machine. So that is the same thing is happening here also. So by typing this particular syntax from Nginx, what it actually doing, it is actually pulling the Nginx image from Docker Hub to your local machine. So it will start from there. So it will pull the Nginx and it will pull the Nginx image from Docker Hub to your local machine. And inside that particular machine, you mentioned that your application is actually running in a folder called /app. Okay, your working directory is /app, and um, you are exposing a particular port. You want to expose your application with a port called 80. So in this case, you have given 80. You can give any other port also. 8080. You can also give 8080, 8090, anything. You can give any port. Okay. Now after this, this is the command copy command, which will actually copy from your local machine. Your local machine address is HTML. This is the source, and this is the destination of the Docker container. Inside the container, it will copy the files which are there in HTML, in this particular .html file, into /user share nginx HTML. So by copying all these files from HTML to this file, these two files like days.html, HTML, index.html will be copied from your local machine to this particular path. You can verify that. Okay. Now this is what the Docker file is about. It is a simple Docker file which demos the how you can actually build a image from. You can actually build your own image, and over which you can run your own application. So by running this particular Docker file, you will create a simple web application which is running inside a Docker container, which will run under Docker container. So let's do that. Let's to run this, right? We can go to terminal, and you can go to the repository and type the command docker build dot. Docker build dot will actually build the application which will build the Docker file. So by saying dot, you mean that is current directory. So that means your current directory should contain the file Docker file. So if you list out, you can see that Docker file is there in your current directory. So by just typing docker build dot, it will actually start running the nginx container. Sometimes it takes it fails in downloading the container. Okay, so it's because it is expecting sudo command. You can actually you can run the docker command using sudo, so that you have advanced privileges. Now running it in sudo actually will, now you can see that the container commands are getting executed. It is exporting the images. It is creating it created layers. So it is here you can see that it has started from nginx as a base image. It downloaded that particular base image. If the image is already there, it will not download again. Then it will start running all the commands. You have seen that the copy command is also there. It has it didn't display, but it has exposed port number 80. Now you can see that Docker is already running. Docker file already got run. Whatever commands are there here to copy the file and all those things, it is there. It has executed it. That means even though you haven't given the Docker file in the command line, it took the Docker file as input and executed all the commands and created an image successfully. Now you can verify it by typing Docker images. By typing docker images, you can see that see that this is what is created now. So you can see that I haven't given any repository name. I haven't given the tag name, right? So you can actually give the tag name also when you actually build when you actually build the um, when you actually build it. So you can actually do that. So let me delete it and again try it. Docker RMI and the image ID, I deleted it. Now let me run the Docker file with tag minus T, and with the repository name, let me give my name slash, and the what is the image name, my HTML, my HTML, and let me say the version is 1.1.1. Now you can see that it again got successfully executed. You can verify the image is created by typing the command docker images. Now you can see that by giving the tag, you have to give minus T tag. So by giving the tag, it has given a name to the Docker image that you have built. It has given a name, Anil my HTML, and with the tag 1.1.1, right? So you can see that, right? Now you can actually run this particular Docker image. Now the image is created, but you haven't run the image. You can run the image by saying Docker run, and the image name. So this is the image name, Docker run image name. Probably you want to give the tag name also. Docker run this one, and probably I want to expose in port number 8010, map to, in the container we exposed it in port number 80. So I will run this particular command. So minus P should be given before the image name. And it got started. Now, by running this particular command, what I'm saying is run this particular application, start this particular container, start this particular image as a container application with exposed port 8010. So you can see that, you can verify that. So let's go to our local host and 8010. Now you can see that your application is running here, right? So you can see that your index.html is coming because you are running under nginx kind of build, right? So by default, if you don't give anything, it actually goes to index.html only. So even though you haven't given, you can explicitly give it also index.html, then also it will go to the same page. If you don't give HTML also, it will defaultly go to the same page, index.html. Now you are successfully able to create your own Docker container. Now you created a Docker container, which is a simple Docker container. On click on this particular page, index.html page, go to this, you actually are redirected to localhost 8010 dash.html, right? And you can see this. Now, now you have seen that how you are actually able to create a simple Docker images, and from the Docker images, how we are going to create a simple container. Now you can see, you can verify that, right? So you can say now I can say by typing Docker ps -a, you can see that you are already running two containers. Before you run one particular container, then you run another container. There are two containers running. So probably you can actually delete one. And so you have seen that by running Docker container, let's say Docker start again. Docker start this particular container. The container is up again. Now you can see that you can run this particular container when you execute Docker run, right? There is a special command called Docker run -d. -d will actually run a particular container in background. So I will show you what does that actually mean. So let me delete this particular container once again. Docker RMI the container ID. Okay. So to delete container, I had to command, I had type the command docker rm. I cannot remove the container. Okay, so I have to stop the container first. It is already running, so I have to stop it. I stopped the container. I stopped the container. I removed the container. Now let me run the Docker run again. I'll show you what actually run in background means. So once I run this particular command, docker run -p8010, this something, this one, right? You are actually holding the terminal because it is running as a foreground process. So once you run this particular command, it will actually hold the terminal command prompt also because it is running as a foreground process. So you can see that your terminal is blocked. You can't type, you can't get your shell prompt. You can actually run the same command as a background process by using -d. -d is the command to run the particular container as a background process. So how, let me see how it works. Let me first delete the container that I have created now. It will be there in Docker PS if it is if it is running as a program process, the particular container should be there. It is running as a background process. So let me see -a, and I will actually remove this particular container. Yeah, so this is the container ID. I stop it. I remove the container by typing docker container. Now the container is deleted. Now I want to run this as a foreground process. So to run as a foreground process, I have to give -d. So by doing -d, you see now the terminal is not blocked. It just started, it run the container. It actually started the container, but it is running as a background process. Now you can actually type the command back. You need not type Control C uh, to uh, to exit from the running process. So -d is actually used to run the docker run command in detached mode. So this way you actually create a particular container, you run the container, right? So now we have learned the usage of a simple Docker file. A simple Docker file can be written to build your own image. In this particular example, you have created a simple Docker image of your own, and from that image you have run a container, and that container is running in your local machine, and you have verified that by going to that particular exposed port, in this case 8010, and see that this particular application is running, right? You can get inside the running container also by executing exec command that I have explained you in the previous session. You can actually use the docker exec command to get inside the container. Okay. Okay. So now we have learned how the Docker file is being used.
So Anil, just one question. If you have multiple containers running, then how do you network them? So this one is talking on say port 80, but then if there are multiple containers which is in a distributed environment, how do you network them and then make the interdependencies?
Yeah, so actually for that purpose only I have exposed this particular port 8010. So basically you can imagine that the container is running and exposing itself in port number 80, but it is attached to your machine, local machine, with port number 8080. So your machine is exposing a port called 8080, and the container is linked with the local machine's port 8010. And so this particular command you can see, right? You are running docker run -p8010 and 8080. So by this, what you mean is like the Docker within the container environment, it is exposing itself, the application, it is exposing the application in port number 80. But to the outside world, that is to our local machine, it is mapped to port number 8010. So you can access this particular application, simple web HTML web application using the port 8010. Tomorrow, if you run another Docker container, you have to expose it in a different port. So there will be no collision. So that container itself can run under port number 80 within itself, but it will be mapped to some other port in your machine, 8012, 80, some other port, right? So you can run multiple containers with different ports. So here you can see in this particular example, right here in the top, you can see you have two Nginx machines. Two Nginx machines are there, and these two Nginx machines are exposed with two different ports: 9080, 9082, 9081. There are two different applications being running, with two different containers being running, but they are exposed in different ports.
So how do you access them from an external environment?
Yeah, so you can imagine we are already external, right? The container is running within its own sandbox, and our machine is external to the Docker. So by typing localhost, you are already accessing from outside. So from your machine, you are accessing a Docker container application. So let me see again. Let me go to the slide again. So you have in this example, right? So your operating system itself is a external machine to the containers. The containers app A, app B, app C are running differently. They are running differently on different ports. On different ports. In the local machine, they are mapped to different ports: 8080, 8081, 8082. So you can access these machines by the specific port. For example, if you mean that you want to access from outside your machine also, so they are different concepts, right? Your local host machine should be exposed with it should be mapped with some IP address. You have to buy IP address. You have to do IP address mapping, or maybe like DNS mapping. You can do that, right? So
correct. So that's what I'm asking. Is it what is the external IP address for this public IP address for this container?
Oh, okay. So right now, so if you can actually, I will show you. You can actually deploy this in a separate machine which already has external IP. Everything is mapped. My machine doesn't have an external IP address. Probably you can actually play with it. Like in our machine, you have something called etcd host, right? Etcd host. So you can actually play with the etcd host, right? This is the file. So in your local machine, you actually can map. You can actually map your local IP address to some other domain name. You can actually say. So this is what mapping I have done for other applications. You can do some other mapping of your own. So probably okay, it is in. Okay, so probably you can play with your etc host to maps to some other IP address. Maybe like you can play with this. Like here, you can actually type something saying that instead of localhost, I will call it some other name, right? So I will say 127 dot. Maybe I'm not sure if I'm doing correct or not. So you can say instead of localhost, you can say my domain.com. So this is all a different concept. This is called a domain naming and IP address mapping, right? So you can probably, it will work. Let me say this. Let me see if it works. mydomain.com. I have mapped 127.0.0 to mydomain.com. So mydomain.com, and 8080, right? Okay. No. Okay. Now you can see that you have mapped internally. You have played with it, saying that whatever requests come from 127.0.0 to domain mydomain.com. I have just put it because I haven't just created any domain. I can actually create my own domain by going to Google domains or maybe my godaddy.com or something like that. I will create my own domain. Imagine that I already have one particular domain, mydomain.com, and I will deploy my Docker application there. And so now I can see that my Docker domain application is actually running in mydomain.com. Okay, and mydomain.com I have deployed it, so I can just access it because it is exposed to port number 8010. I will just go to mydomain.com :8010, and by going to that, you can see that our application is reachable there. Now you can see the same experience. I will explain you in real time how we can actually really deploy a Docker application from your local machine to a AWS machine right now. If you already have AWS account, you can also try along with me now. So we will discuss this in upcoming few minutes. Okay. Now let me revert back my thing. Okay. Okay, now you have seen that we were successfully able to create a Docker container. What if I want to make few changes inside the index.html? Maybe I want to make this Friday also active. So by doing this Friday active, what I would expect is the Friday should also come as with a blue shade in it, right? So what shall I do to make it happen? So by just making it as Friday in my local machine, I will not be able to do that. Let me see that now. See, even though I made my Friday as active, it didn't change it here, right? So I want to change the Friday also to blue. So for that, what I have to do is like, again, I have to rebuild the Docker image. So, so this particular repository is actually present outside the Docker container. We made, if you see in our Docker file, we have made a copy of the days.html index.html inside the Docker file. And so there is another copy of days.html and index.html inside the container. So for that purpose, even if you make a changes inside the HTML file, it doesn't reflect immediately. So what we want to do some sort of, we can do, we have a solution for it. We want a solution such a way that whatever changes we do outside the Docker should be reflected directly inside the machine, inside the Docker container application also. So that is what we wanted to do. So in order to do that, we have something called volumes. We will mount /html .html folder to a volume. So that we can actually do using something called Docker Compose. So you can see this is what we are doing. So this is another way of building a Docker file. So previous example, we see that we have just run our Docker command by using Docker build, right? By using Docker build, we build the container directly. Now, instead of that, if we want to run Docker file along with that, we want to also mount external volume inside the Docker. I hope you understand what I mean by mounting the external volume inside the Docker, right? So what does that actually mean is, in your machine, which is there in .html folder, it will be mapped to user share ngx html folder. So it is a mapping. In the previous example, what you are seeing in the Docker file, what you are seeing is, you are explicitly copying all the contents of HTML file inside the Docker file, Docker image folder path user share nginx HTML. So you are just copying all these contents from HTML to this particular folder. So that is what you are doing in the previous example. So instead of that, if you use the volumes attribute here, it will actually copy. It will not copy. It will do a mapping. So whatever files are there in HTML, it will be mapped to user share nginx HTML. So that is what we are going to do. So this is another way of building your application. So here, Docker Compose has its own syntax. You can see, it starts with the version and then followed by services. In the services, you can have multiple services in it. In our example, we are creating a simple service, only one service. That service is called web, and it has few commands here. So you say that it is trying to build from the file called Docker file. It will try to build the file from Docker file, and it will map all the contents of the file from .html to user/share nginx XML. So .html is nothing but this particular file, whatever you see in your terminal, right? In terminal, you can see that by typing ls. See that, right? So this .html actually means that these two files only, this HTML and this one, right? So those .html is actually mapped to user share nginx HTML. So that's what we actually do. So we can simply run this particular Docker compose YML file also. So let me go to the slides if I have covered all things or not. Okay. So have a look into the slides. So this is exactly what I have been covered right now. So this is all I have already explained in the last session. In the last session, I have already explained what is now. Now also I have explained what is basically a Docker container, what is a Docker hub, and how the Docker hub is actually pulling the images. How do we push the images to Docker hub, and so on. Okay, we didn't actually see how to push the Docker images, right? So we can actually push the Docker images also. So let's now you know that we have built our own image, right? We have built our own image, and we can see the image that we have already built by typing the command images, and you can see that the image that I have built is Anil but be my HTML with tag 1010, right? So this particular image I can actually push into the Docker hub also. So that's what this means actually. Docker image to push to Docker hub. So right now you can see that our Docker hub doesn't contain this particular image Anil but be my HTML, which I have created my now only. So that particular Docker hub, you can see your own repository. So your repository doesn't contain that particular image. You have only two images, but it doesn't contain my HTML image that you have built right now. So by using Docker build, you have created this particular image, right? So you can actually push this particular image by doing Docker push. Docker push, what is the image is account name. This is the account name under which you want to push the repository. You want to push the image my HTML with tag 1.1.1. Okay, so by doing Docker push, it should actually push to Docker Hub. So it is preparing. It is preparing in terms of layers. It is creating layers and pushing each and every layer one by one. So it is pushed all the layers. It pushed 5 layers now, and finally it is pushing another 3 layers parallelly. You can see that progress by looking into the command terminal. So after, so it has totally number of 1, 2, 3, 4, 5, so total 8 layers. So it is pushing 8 layers as a part of push command. So now, as a part of push of this particular repository into the repository Anil but B, you can after it is successfully done, you can see that it is actually pushed in my Docker Hub here. Now let me refresh. So you can see that my HTML is there here. So I have just pushed my own repository. I have created my own image. I have created my own image and I have pushed it to the Docker Hub. To do that, you have to follow some syntax rules. So you have to give your account name initially, followed by the image name with tag. So this is what account name, image name, and tag. Okay, so this is what is the syntax to actually push a particular image from your local machine to the container. So now even if you delete from your local machine, even if you delete it, you can later again pull it back from your registry, which is there in Docker Hub. So you can do that. So okay, let it be. Now you know how to actually create your own image. Now you know how to create your own image, and you have how to create your own image in your local machine and using Docker file, and how you actually push the image that you have created in a local machine to Docker Hub. That's what you have learned right now. Now, another thing that you wanted to understand is about Docker Compose. So if you have multiple Docker containers, if you want to run volumes, if you want to run multiple services, then the option that you have to go with is Docker Compose. So that's what I have explained, So by using Docker Compose, you can run multiple services, and each, in this case, you have this particular web application running with name web. Tomorrow you can actually create another service also, like maybe like you can create another service, and you can maybe like you have to create a DB service. So you can say Postgres service, and you can execute Postgres specific Docker information. So the Docker file need not be immediate Docker file. It can be in a parent folder, like parent folder Postgres / Docker file. So it will actually build from another called Postgres, and it will build a Postgres service. So that you can do. For the simplicity, we are actually creating only one service. So this is what is the Docker Compose looks like. We are just going to create a simple Docker file, and you are actually exposing it via Docker volume. So in order to execute this, all you need to do, let me clear the old files now. Let me clear everything. Let me delete the container. Okay, let me stop the container first and delete the container, and then delete the image also. Okay. Now I successfully deleted my image also. Now I will actually run the Docker compose. I think the Docker compose compose up. So by running this particular command, it actually tries to create. I think I didn't run sudo. Maybe it will give error. But run the Docker compose file. You just need to type the command Docker compose up, right? Okay, okay. It's successfully started the application. So now we started the application. You can actually verify it. So in your Docker compose, what you have mentioned is you are actually porting it to 80 port. Okay, so there may be a conflict. Okay. Okay, so there was nothing in port number 80, so it worked fine. Now you can see that the Friday also got highlighted, right? Because it is actually referring to your local host HTML page. Now, suppose I want to change dynamically. I will again say instead of Friday, I'll also make Thursday as active. So I made Thursday also active. Now I just refresh this page. Now you can see that Thursday is also getting active. So you need not actually rebuild your entire Docker file again and again. That is the beauty of mounting your external volume into a Docker container. So that which you have done it using the Docker compose file volumes feature. So under volumes, you have said that all the contents which are there in HTML .html folder should be mapped inside the Docker with this path, which is typically nginx web server path. So whatever changes you do inside your local HTML folder gets reflected immediately inside the Docker. So that's the way how you actually dynamically mount, make changes from outside only instead of rebuilding the whole Docker file. So let me actually revert back. Let me make only Saturday, Sunday as active. So this way, you can see that you can dynamically change your contents from outside the Docker, and it will reflect immediately in your application. In this case, simple web application. So now you have learned what is Docker Compose. So Docker Compose has many list of commands, like you have made Docker Compose up, right? You can see this Docker Compose up. It is actually blocking the terminal. The same thing, you can actually run the Docker Compose up -D option to run it as a background process. So instead of running it as a foreground, now I am stopping the container by doing Control C. By Control C, it will stop the container now. Now it has stopped the container. Now the same I can actually run by using -D. So by doing -D, it will not block the prompt. So still again the container will be running. Okay. So Docker console of -D. You can actually do Docker compose down also. So there is a command Docker compose down. It will actually stop the container. So whatever container is started by doing Docker compose up will be shut down by command Docker compose down. So there are many other commands with respect to Docker compose. You can actually play with each and every service. You can list the service. So you can see like Docker has multiple services, right? So you can actually see which images are being downloaded, which images are being used for each and every service, what are the attributes of each and every service by Docker specific commands. So that you can actually look into the specification, or you can do the manual help. You can go to manual help and see what are the different commands for Docker compose. Maybe yeah. So you can actually see the Docker compose commands like specifications, which should be there in the Docker official website. So So these are the yeah. So we can actually see a lot of commands like Docker compose help, maybe like in official website also somewhere it should be there actually. Hmm. Yeah. So maybe like Docker compose help. Yeah, it gives list of all commands available under Docker Compose. You can actually do a build, you can convert, copy, create, down. We have used the basic thing down and up. You can actually run other commands also. Like for example, this is seeing the web specific server specific uh, version. So you can just type Docker version out here, and you can see what is the specific build that you are doing under the service web. So like in Docker Compose you have service called web, right? So you want to see more details about the web, so that for that purpose you can actually see you can run this particular command. What are the environment variables belonging to the service web which you have run with Docker Compose, right? So by doing that, it will say you all the environment variables that were exposed under web service. So this is what is the command example. Similarly, you can play with other command also. Maybe you can do Docker compose ls. So you can see that under Docker compose there is another yeah, and the Docker is running under Docker compose Docker API SSX. Maybe like you can actually run up with detached mode and again run Docker compose ls. So what it does is like now you can see that you have started a particular Docker service by using Docker compose with detached mode, and you can see the list of all Docker services which are running. Now my first app is what you are running here by using which we have executed just before that, right? So you have now two in the list. Now once you do Docker compose down, so you can see that one container is down. So again, you just type Docker ls, you will see that it is removed from the list also. Docker compose ls will not list that particular service, Docker service. Okay, fine. So now we have what we have learned is how to make use of Docker compose. So if you want to run multiple containers, if you want to run external volume, you have to create your own Docker network. Then you have to use Docker Compose. And always remember, Docker Compose is something specific to your local machine. You can play with multiple containers. You have create multiple containers in your local machine using this Docker Compose YML. So it will reflect in your local machine. It will create as many services as you want in your local machine. It will create as many volume mounts as you want in your local machine. So that is what you do using Docker Compose YML. Okay. Now we have learned about Docker file, what is Docker file, and we have learned about what is Docker compose.yml. Okay. Now we'll learn about a specific CI/CD tool. CI/CD tool called Travis. So you know about, like, we have already discussed the concepts of CI/CD tool, what exactly is meant by CI/CD. We also discussed about other things also, like Jenkins. We thought that we'll discuss more about when we are actually implementing. Now similarly, this Travis is also another CI/CD tool, but it is a commercial tool. Commercial tool, and it is actually like it is like Jenkins only, but it has its own way of building a continuous integration and continuous deployment. And this Travis is actually have tied up with multiple vendors like Azure, Google, Docker Hub, GCP, Google Cloud Machines, and many other vendors. It has actually tied up with it, and based upon the where you want to deploy your application, you can use that specific commands. right? So in order to make Travis working with your build, right, you have to create a Travis account, one Travis account. So you just can create your Travis account. The steps are pretty simple. Go to your Travis website and open an account. So while opening account, it will ask for it will ask for your GitHub account. So basically, Travis mostly works with GitHub. You can opt for other repositories also. So you can actually open your Travis website. Okay, so I have already created my account. It will ask for credit card information because it has different plans. You can go for free trial plan, which is a 30-day free trial, and it is free, and it is free for all open source projects. And for private projects, after 30 days, it will charge. You can actually buy other plans as well. But to start with, you can actually open account with free trial. So just open a free trial account. It will ask for your credit card information, enter the credit card information, and then you can use Travis for your continuous integration and continuous delivery process. So it will you log in with you have to log in with your GitHub account, and you have to map your GitHub repositories with Travis. So I will show you an example of how you can map your Travis account with GitHub repositories, and how you can actually perform CI/CD whenever you do a push to your branch. How the builds are being generated, builds are being run, and tests getting run, and after a successful deploy, how we can actually after a successful build, how you can actually do a CD pipeline, basically deploying it to different places, right? So I will explain you one by one. In this example, what we will do is like our web application. This is a simple web application that we have built. So probably we can actually map our repository, this particular repository, my first app, to Travis, and we will deploy this app to AWS account. Okay. So that is what we are going to see. So for that, we need to open a Travis account, and also we need to have a AWS account. We will do it later. So just create a Travis account, free trial account, and then you have to integrate it with your GitHub. So as soon as you do create your Travis account, once you go to your GitHub account profile, when you go to your settings, here you will be seeing something integrations. Right? In integrations, in applications, you can see Travis here. So because you have integrated your Travis account with the GitHub, you will see that the integrated application will be there in your application list. Now you can add as many repositories as many you can. I have already added a few repositories here, so I can actually delete them and re-add them. So now let's see. Our repository of interest is my first app, right? So we are interested in my first app. So this is the application that we have run right now. So we have run a simple HTML application with these HTML contents, right? We want to run our CI/CD pipeline with this particular application, my first app, right? So for that purpose, I have to add my first app repository. So I'll integrate my first app repository into Travis. Now I have added my first app in my Travis, and I guess just save. So once I save it, I will be redirected back to my Travis account. So here in my Travis account, I can see I have an option called sync account. So it will sync latest changes from GitHub, what I have mapped. So by syncing, it will sync all the repositories which I have mapped with Travis, and list out here. it will list out all the repositories which have synced with GitHub. Now let's wait for some time. It is trying to sync from GitHub. And after syncing, it will show my first app repository is mapped with Travis. Now, after it is mapped, after seeing the mapped repositories, I can actually build. I can actually trigger the build for every commit, or I can actually run the build for. I can trigger a daily job to run the build every day. Then I can build nightly builds and so on. Okay. Okay, it's taking some time. Okay, it is taking some time to sync. Let it sync. Meanwhile, I can just go to dashboard. Here you can see that my first app is already there. It's already there. It is already mapped. So you can just go to the my repository. Now you can see all the builds. What is the current latest build happened? What are the list of repositories which are mapped with Travis? You can see the build history in the past, how many builds were happened for this particular repository, my first app in GitHub. So all these things you can actually see. So there is an option here in the right side, more options. You can actually trigger your own build also. You can see other settings as well. Under settings, which I'll explain you what we can do in settings also. You can actually trigger build and so on. So these things you can actually do using Travis. So let's see how you can actually trigger a build using Travis. For that purpose, you need to create a file called .travis.yml. So you can, I have already created a file called travis.yml. So this is what I have created. So this is what is necessary to make integrate Travis builds with your repository, your GitHub repository. So the first step is open a Travis account and you map your GitHub repository with the Travis account. And after mapping the GitHub repository, in this case, my first app is mapped with your GitHub repository. After it is done, you have to create a travis.yml. After creating a travis.yml, you have to say Travis what to do with this particular repository via travis.yml. So in this case, my main aim is to trigger a particular build on every push to the main branch. I want to trigger a build, and after triggering a build, I want to deploy it to my AWS account. Okay, so that is what I am doing it. This is the syntax that I am doing as a part of Travis build, right? So there are different steps. So in this particular example, I am only doing the deploy step. I can do build step. There are different. Travis has its own specification. I can do build step, on successful build, on failed build. There are different configurations that I can do. So on success, I can add a separate tag also here. Build on success. I have already there. So I will explain on success later. Now for now, I will explain you about only the deploy. How to do a deploy to AWS service. There is a service called AWS service called Elastic Beanstalk. So how for every commit to the main branch, I want to deploy my code to the AWS service Elastic Beanstalk. So that's what I want to do. So that is what I'm trying to accomplish as a part of this transcript. You can see that. So hopefully you already have a AWS account. So you can go to AWS account, AWS console. Go to AWS console, and you can see that there is a service. First, you sign into the console, and there is a service called Elastic Beanstalk. So Elastic Beanstalk is a web application management service. So Elastic Beanstalk is easy to use service for deploying and scaling web application services down with any kind of applications, Java, .NET, PHP, Node.js, or any kind of application, or Docker also. So in this case, we will try to build a Docker application into AWS Elastic Beanstalk. So that is what we will try to do. So you have to create an Elastic Beanstalk service instance. So you have to create an application, Elastic Beanstalk application. So this is one button. There is a button called create application. You can just create a Elastic Beanstalk application. And the goal is to deploy your application inside your Elastic Beanstalk. So you can just create application and then deploy, and we'll take the help of Travis. So end-to-end CI/CD pipeline, you can actually see live demo using this all these tools, all these tools and services. So in the services, you are going to use Docker service, and you are going to take care of CI/CD pipeline tool called Travis. And with the help of Travis, what we are doing is you are actually bundling your application. You are bundling your application, and then you are actually pushing it to AWS web application service web application management tool called Elastic Beanstalk. So in order to push that into web application data, intermediately you are going to upload your entire application as a zip bundle in a particular bucket of Amazon S3. So you have Amazon S3 service also. We are going to use Amazon S3 also, and you package all your entire application as a zip file, and you upload it into your Amazon S3. And from Amazon S3, you will copy that particular um, your application, bundled application, into Elastic Beanstalk. So that is what we are going to do. Okay. So let's see. So I did a quick introduction of Travis, right? You can also actually create your own account. Meanwhile, you can actually create a free trial account and try end to end after the session, or now only you can try the end to end application deployment. Okay, so let's see what we have covered till now. Yeah, you can go through these slides once again. Okay. So I am still getting started with Docker. Okay. Now we have covered this. Now we have quickly explained the things, lot of services I have quickly introduced you. So let me just list out the highlights, what I have introduced. So we have introduced Docker file to build, right? So we have Docker file now. Now we have something called CI/CD pipeline tool called Travis. So we have tool called Travis. So what we want to do is, like, whenever we use Git, we do a commit and we do a push, right? So when we do a push to Git, we want Travis to pick up this particular pushed commit. When we do a push on, suppose like we want to push on main branch, on pushing on the main branch, we want Travis to pick up. So what the Travis we are expecting to do is, like, pick up this particular build, try to build it, on. After the successful build, we want Travis to deploy it to AWS. So in the AWS, we are using two services. We are using S3 service, and we are using Elastic Beanstalk. We are using Elastic Beanstalk service. So these are all we are trying. These are all the tools we are trying to use now. So we are using Docker. We are using Travis. We are using GitHub to push into it, and we are taking help of Travis to deploy into AWS services, AWS Elastic Beanstalks via S3, and from S3 it will actually pick up into the web application will be deployed into Elastic Beanstalk. So this is what we are trying to accomplish as a part of CI/CD pipeline. So this will go through this entire pipeline as of now. Now you always remember, like our application was already running. This was the application, this is a simple application which is running in localhost, right? And I think Pranav asked me that how to deploy in a separate machine to the external world, right? So that we are going to see right now. So now instead of in local machine, we will have some domain.com/days.html at the end of the deployment. After the deployment, we see that it is deployed into a completely external machine. So as this part, now let's go step by step. Now we want to elastic beanstalk to be created, right? So creating, we already introduced what is elastic beanstalk. We will just go and create an application in AWS console. Now let's go and create an application. So let's say the application name as my first app. And what kind of application are we going to deploy? We are deploying a Docker application. So we are going to run a Docker application. We are going to run a Docker application on a Linux machine. So Docker running on 64-bit Linux 2. This is what we are going to run, and we will just go with the recommended version that AWS gives to us. We are using 3.4.17 as the recommended version. Okay, and so for now we can actually upload the code directly. For this case, we will just create a sample application. Okay, now once we click on the create button, it will start creating a sample application for you. So as a part of it, it will create an application, it will create an environment for you. Now you can study this step by step what it is doing. Okay, now be careful with where you are actually, be careful with what region you are actually selecting. I have selected Mumbai region. This is the closest region to me. So if you select the closest region, then it will be a little bit faster, other than if you choose a region belonging to US, then it may take some more time. So you selected the closest region to you. I have selected Mumbai, which you can see here. Asia Pacific South, AP Pacific South one is Mumbai region. So it is trying to create an application in this particular region, AP South one. So you can see what is going on. Now it has created an application. It is creating an environment for you. So it is creating an environment here. So it will take some time. Let's wait for the environment to get created. So meanwhile, you can ask, we are quickly introducing a lot of services. So feel free to ask me questions. If you have any doubts, just let me know. I will clarify. So now still the environment creation is going on for the application. So we can see meanwhile we can see that clicking on this application, this is what the application that you have created, and this is the environment that is getting created. It is in state of pending. After the after the environment is completely created, then the status will be okay. It will be active. So you can actually see again, you can click on this environment. You can see what is going on here. So there are multiple things that will be going on. So it is creating some monitoring CloudWatch. It is going on creating a lot of things. So it is actually creating a storage bucket also. So it is using S3 bucket as a intermediate deployment, where all the deployments will be stored. Deployment packages, whether it is a Java application, it will store the jar files, or if it is any bundle, node.js bundle, node.js bundle. So those bundles will be actually stored in S3, simple storage service. It will be stored there. So it is creating a bucket for deploying into Elastic Beanstalk. So it is creating, it will take some time. So once you have created your Elastic Beanstalk application, now you want this application to be used for deployment. Now your environment is ready, right? So you remember you just selected a sample application for deployment, right? So now you can go to that, but this is what it is saying, the URL of the deployed sample application. So just click on this. So this is the sample application which it has deployed for you. So you can see that the application is running fine. And the domain that was given to us is this particular domain, my first app, so on elasticbeanstalk.com. So this application, this URL is being used as the web URL for the application which is deployed. Now you have the deployed application, this sample application. Our goal is to deploy our web application, which is our HTML web application, which we have deployed in our local machine here. We want to deploy it in our AWS. So that is our goal. Now we create, after creating an Elastic Beanstalk application, we will create a user to deploy. We will create a service account user to deploy to the Elastic Beanstalk. To create a service account, you can use a service, AWS service, IAM AWS service. So go to IAM and create a user. Okay. So go to IAM service. IAM service is to actually used to create users, groups, and policies and so on. So you can actually create your own user. Go to the users tab, and you can create your own user. So to create a user, you can just go and add user. So add user and give, because it is a Travis user, you can say Travis user, and so you have two options to actually create the user. So you want to say what kind of user is it? Is it a the human user who wants to enter via password? Whenever he wants to log in, using password and so on, or whether it is a programmatic user, which can actually run on behalf of a user using a access key ID and secret key. So we will go with programmatic user because we are automatically deploying via Travis. So we are creating a Travis user who has programmatic access. So this is what we will select, and next. And so what accesses policies you want to use? So attach policies. So you can use existing policies only. So because you want to use S3 service and you want to use Elastic Beanstalk service, you can go for Elastic Beanstalk. You can add this existing policies which is already built. So you want to use Elastic Beanstalk service full access. So Elastic Beanstalk service, Elastic Beanstalk. Elastic Beanstalk. So there is a service called Elastic Beanstalk Administrative Access, right? So this is what you have to select in order to do the deployment to Elastic Beanstalk. Select this particular service, and after that you want to do a S3 service access also. So AWS S3 full access. This is what you want to select. So you select these two policies from the existing policy. You attach these two policies directly, and then go next. You can skip the tags thing and click next. And by doing this, you create a service. So you are creating a Travis user service and with these two policies. Okay. Now after once you do this create service, it will create a user called Travis user. And I have already created a user before. So I will just use the existing user only with the same role. So in the user, I already have a Travis CI. I don't want to create another service. So I have already used this Travis CI service, and I have downloaded the security credentials of it also. So access key and secret access key, private access key already I have downloaded as a CSV file. So I have created a user, and these are the secret access key ID and secret key of the user that I have created. So these this secret key and access key and the secret access key that I can use. I can use these in order to provide credentials for Travis to deploy to AWS. So I have to use these particular services, these keys in Travis. So I will go back to Travis now. So in the Travis UI, so in the Travis, I go to Travis UI and go to this particular repository, my first tab. So I have to give Travis the credentials via those secret key and private key actions via environment variables. So you can see that in travis.yml, I am already mentioning that my AWS key ID, my AWS secret key, secret access key ID are present in environment variables, AWS access key, AWS secret key. So these are already there, right? So I want to, these are variables, AWS access key. I want to initialize these variables in the Travis here. So I will go to the Travis. Here I have created the environment variables, AWS access key, AWS secret key with the values. So these values I got it from the CSV file. So using this CSV file, I copied those values here, and these two variables I have initialized it in the Travis for this particular repository, and I save it. Once I enter this value, that means I am ready to have access rights to deploy to AWS S3. Now, so this IAM user is already having the access to S3 and AWS Elastic Beanstalk web application deployment also. So both it has access, right? So now I will go and create a S3 bucket. So you see, like in Travis, I already mentioned that I am using a bucket, right? S3 bucket. So I have already mentioned the bucket name. So the bucket name is my first app bucket. So this is the bucket name that I want to use. So I will make sure that I create a S3 bucket in my AWS account, S3 account. So go to AWS S3. Let me see if I already have AWS S3 bucket also, or you can again create. So to create a bucket, you can just click on the create bucket and enter the bucket name, my first app bucket, select the reason. In this case, the reason is AWS reason. And there are other configurations which you might not want to change. It is okay to have those values, and then you just create the bucket. So once you create the bucket, I already created a bucket here. So this is what the bucket is, my first app bucket. Okay, so now I have created this bucket. Now I will use this bucket. Inside this bucket, I want a folder called Docker, because in the travis.yml, I already have used the bucket path. So the bucket path, I'm saying that I will use the path called Docker. So I am creating a folder called Docker. Inside this Docker, I will be having all the builds, right? So these are all the builds that I'm going to have. Let me delete it for now, so that so let me delete it. So now I can see that my bucket is empty. My Docker bucket is empty right now. So you have created S3 bucket called my first app bucket. And in my first bucket, you have a Docker folder. So in this folder, all your deployment bundles will get copied. It will get uploaded. And after it gets uploaded to S3, it gets deployed to our AWS Elastic Beanstalk service. So you can go to Elastic Beanstalk service and environments. You can go to the Elastic Beanstalk service, and this is your application name. So your application name is my first app. So you can see that you have to verify that your application name here is my first app, and these are both same. My dash first dash app, right? So my dash first dash app is the application Elastic Beanstalk application name, and it is should be there in Mumbai region. So just verify that in the top right, you can see that Mumbai region. So by clicking on Mumbai region, you can see that Mumbai region is nothing but AP South 1. So look into that reason. So this is the reason. The reason should be AP South 1. And then go to the verify that environment name. So your environment name is capital M my first app dash env. So here this should be the environment name my first app dash env, right? So this should be the environment name. So your environment name is there in travis.xml, app name is there in travis.xml, YML, and you have configured your AWS key, AWS secret key in Travis, so that you can add it in Travis YML here. So in more options, you can see that settings, AWS access key, AWS secret key. So this is what you are getting. So, and bucket name you have already created. So the bucket name is my dash first dash app dash bucket. So that is there in AWS S3 bucket. You can go to AWS S3 bucket. AWS S3 bucket and verify that the bucket name is my dash first dash app dash bucket, right? My dash first dash app dash bucket. And the bucket folder name is Docker. And you want to run your Travis build on branch main, right? On GitHub, in the GitHub branch, the branch name should be main. This is what you are saying to deploy info to travis.yml. So you go to GitHub and you can actually verify my first app has a branch called main here. So there are many branches, out of which main is one of the branch. So whenever you do a push to make any changes to this particular branch, then travis.yml will automatically pick up. It will actually deploy your application to Elastic Beanstalk via AWS S3 is AWS S3 bucket. So this is what will happen. That is what we'll see. So let's go ahead. Let's make the change. Okay. So this is in Visual Studio. We already have extension, GitHub extension. I can just use this GitHub extension to actually commit. It saves a lot of time. Otherwise, I can do the commit here also. I can see the status. I can see what changes I have done here. So in this case, I am making some small modifications. Let's make a small modification like this. Okay. Now I want to push my changes. So let's for better changes, let me make a better change. Let's go to base.xml and let me make a small change here. I will make Saturday inactive. Saturday is inactive, and Monday, Tuesday, Wednesday, Friday up to only Sunday is active. I am going to push these changes. So I will just push my changes. So make I'm going to push it into GitHub now. So I am pushing it. Okay. So I am committing it and I am doing a push. So I did a push now. So as soon as I make a push, I can verify that the Travis will get picked up. So go to Travis here in the dashboard in the my first app build history. You can see that a new trigger has happened. So for a push in the main branch, I made a commit called make Saturday inactive. So that push has triggered a Travis build. Now the Travis build is happening now. So go to this particular build and you can see the job logs now. What is happening? You can see the build has started for Travis. So what we are doing now, the Travis has picked up that particular commit. Travis picked up that commit based upon the travis.yml. It is trying to build the commit. It is building the commit, and in the Travis we have mentioned what to do. So it is starting Docker, because we already mentioned in Travis that it is of build Travis is of type Docker, right? So we are saying that the Travis is of type Docker. So it is doing a Docker containerization. It is building Docker container, and after it is done, it started deployment of the application also. And this is something peculiar. It comes like deployment is done, your build is done, right? Now build is done. Now go to the S3 bucket, your bucket, inside the Docker. See, now you can see that the build bundle has actually was deployed to S3. So this is the bundle that was deployed to S3. And let's go to Elastic Beanstalk also. In the environment, we should be able to see the deployment. So go to Elastic Beanstalk, open it in a new tab. So here you can see that in the environment, what has happened. You can see that a new build has been triggered, right? So this is what the new environment has, a new build has been deployed. So the Travis has built a new deployment into Elastic Beanstalk, and you can go to the application. So health is also seems to be okay now. Now you can actually go to the application, my first tab, and you can actually click into this. See, your application is deployed into AWS domain. So you can see that our Docker container got deployed into AWS Elastic Beanstalk. So in this particular domain, our application is running. Click on this. You can see the application, whatever commit we had done, we have made Saturday as inactive. Now you can see that Saturday is inactive here also. Okay. So what we have learned is we have used AWS Elastic Beanstalk services to deploy our application, our simple application base.xml. We have created a Elastic Beanstalk Docker type application, and we have deployed our simple application from GitHub with the help of Travis. So today we have learned a lot of tools. Okay, we have learned Travis, a simple Travis YML, how to create a simple Travis YML, how to use Elastic Beanstalk provider in Travis.yml. There are many other providers also. I think there are a lot of providers actually. So Travis supports these many providers officially. So you can see these are all the providers list. So out of which AWS Elastic Beanstalk is one. So we can actually deploy it to other services also. We can deploy it to Google App Engine. We can deploy it to Heroku and many other things. We can deploy it to Azure also, Azure Web Apps. We can deploy to AWS Lambda. So we have used AWS Elastic Beanstalk. So so these are the configurations that we need to use when we used to deploy Elastic Beanstalk. So like what these values, all these values that you have got, these all values you have actually got it from these specifications only. So they have given what we can give: access key ID, secret access key, reason, environment, bucket name, and all these things. Whatever you are typed here, app name, environment name, access key ID. So those all specifications Travis has given us under Elastic Beanstalk deployment. Similarly, if you want to deploy into Azure Web Apps, for example, you can go to Azure Web Apps, and here is the configuration to deploy from using Travis to Azure web apps. So these are all the parameters that you can actually give when you actually deploy using Azure web apps, when you want to deploy to Azure web apps. So you can just follow these instructions. Based on these instructions, you can actually create a travis.yml. And once you create this travis.yml, you are good to go to deploy to Azure web apps as well. So there are a lot of other providers. So based upon your company's requirement, you can use the appropriate provider of Travis and perform the deployment CI/CD pipeline. So you can actually do continuous integration and continuous deployment. So this is the example of doing a deployment that I have shown to you. Okay. Okay. Now we have learned about travis.yml. So if you want to have a reference, the GitHub tool is already GitHub source, entire source code is available to you. You can just go to our CloudX lab course. In our CloudX lab, we have reference to the repo. You can actually try it by yourself. Where is the code? Yeah. So here, go to GitHub CloudX lab. Here, go to our courses, and here go to this particular course which we are learning right now. So this is the GitHub. So I would encourage everyone to actually clone this GitHub repository and try it out yourself. So in this example, we have learned a typical example of deploying a single Docker container, a simple Docker container, which is a simple web application Docker container, to AWS Elastic Beanstalk. So that's what we have actually learned right now. But what if you want to deploy multiple containers like Docker Compose we can use? How can we do that? So that one we will actually learn as a part of next topic. So before that, let me see if I have covered everything in this topic. Okay. Yeah, we have covered most of the theory. We have covered how to create a simple static web page application, which is Nginx web application. And we have seen what are the basic commands we can run using Docker, and how to run the application within your local host machine, and how to use the Docker Compose, and how to do continuous integration and continuous deployment using travis.ci. What is Travis? How to create a Travis account, and how to write your own travis.yml. This is how to create what is Docker Hub. We also learned about how to push the image to Docker Hub. This is what we had learned. What is the syntax of pushing a particular image to Docker Hub? This is syntax. This is what we have learned. So as soon as we have learned that as soon as you push to Docker Hub, it goes to my Docker Hub. That's what we learned here. So as a part of Docker push, the Docker container went here. And yeah, so we just went to create a new repository and cloned it, and we learned about how to use Travis Circle continuous integration, and how to use AWS. Okay, how to sync your account. We have seen how to sync your Travis account, how to add a new account. So I can actually again go through it so that you remember it. You have to try it by yourself. That is the best way to learn. So you can just go to Travis, go to your account settings. The settings, you have integrations, applications. Here you should be able to see the Travis CA, and there you can actually add, remove repositories of your interest. Okay, so this is what you do. Okay, now we have covered everything, and afterwards we have seen all these steps, how the Travis is working. In our case, we don't have any test cases, so it simply builds and deploys it to AWS. If there is any test cases, then it will actually run the test cases as well. Okay, so this is what we have seen in running demo. It actually, so we actually tell that we want to build a Docker application, and then we need to build the image using Docker file, and we have to tell Travis how to deploy to AWS. This is what we have done. We have learned about the syntax of Travis to deploy it to AWS. What is the provider? The provider is Elastic Beanstalk. So these are all things we have learned. Okay. Now we have screenshot of all the things that we have, which I have shown you in the past half an hour. I have done end-to-end continuous integration and deployment in the past hour. That's what the slide is. So for reference, you can again refer to this particular slides and try to run on your own using all these tools. Create your own AWS account and use Travis to deploy to Elastic Beanstalk of AWS. And probably you can actually try Azure Web Apps. You can also go for Google App Engine. All will be the same. So you can use the same Travis to deploy into multiple cloud providers. You can also use Heroku also. So I have given you the list of all providers Travis actually supports. So whatever is of interest, you can go to that particular provider and see the specifications and follow the steps to deploy to that particular service, your web application. So that's what we have learned. Okay. Yes, so you have seen how the environment variables are being created in Travis.yml. So again, I will quickly recollect you. So this is what in the settings in Travis for this particular repository, we have settings. In the settings, you can create the credentials for AWS, using which you can actually deploy to AWS services. And in this case, we have used Elastic Beanstalk. Okay, so we have gone through how to use environment variables. What is the URL, whenever you create Elastic Beanstalk, how to go to that particular URL. So this is a URL we have seen, which was given to us by AWS when you create Elastic Beanstalk. This is what we have learned. Okay, so we have a sample application, and after that we made a IAM user. We created a simple IAM user, Travis user, which is of programmatic, which has program access rights. So we have program access right permissions we give, and so we have attached a few policies. I have attached AWS. Here the slide is a little bit outdated. This policy is no longer there. Elastic Beanstalk full access is not there. Rather than that, we have something called administrator AWS Elastic Beanstalk. So that you can actually verify it by going into your IAM account. And you can see that in the policies, for Travis CI, you can see that the policy name is little bit changed. So it is like administrator access AWS Elastic Beanstalk. So AWS services are always evolving. So there will be little bit changes. We need to get updated to it. So in the slide, instead of administrative access, we have something called AWS Elastic Beanstalk full access. It is no longer supported by AWS. It is not there. You cannot find it at all. So instead of that, you can use alternative. So you have access to Elastic Beanstalk via this policy. You attach this policy, and after you create a user,
You provide access key, secret key to Travis after creating a access key, secret key. You do the continuous integration deployment via pushing. Yeah. So you have to create S3 also. We have seen that we have to create S3. Now we create S3 bucket, and inside that S3 bucket we have created a folder, and afterwards we mentioned all those variable S3 variables, AWS Elastic Beanstalk variables, everything in travis.yml. So in travis.yml we give all those details. We filled all those details appropriately, and we mentioned that any commit that happens, any push that happens to the main branch via this particular syntax, deploy on branch main. That's what we did. And so after that, we make a small change in our GitHub and we just push into the main. After we push into the main, the Travis will automatically pick up and start the build and do the deployment. So after, at the end of the day, deployment happens. Now the deployment gets picked up, and you can verify it by looking into the application in Beanstalk and see that the latest deployment has happened. By clicking on that particular link, you can see that our web page gets opened. Our web page with days.html gets opened. You can verify that. Okay, so this is what we have learned now. So instead of having the main branch, we can also give sub branches also. So if you want to have another type of build environment, you can say, you can add another provider also. We can have list of providers. So in this case, I have just made two providers lists. Both are Elastic Beanstalk only. So I can say this provider will work on branch main, and this particular build will work on branch testing. So I can actually create a new branch called testing. And in this branch testing, I will use the same provider for this demo purpose. So the basic idea is Travis can actually build and deploy to multiple providers like Elastic Beanstalk, and also to other, like suppose here you can use Azure Web Apps also. So you can just say Azure Web Apps. Not this, we can just go to the Travis specification and give the appropriate Azure Web Apps also. So you can just give Azure Web Apps. So here you can say Azure Web Apps provider name is something like this, right? So you can just give that also. Like you, instead of Elastic Beanstalk, you can say on deploy to two providers. Deploy to provider Elastic Beanstalk when there is a commit on branch main. Deploy to provider Azure Web Apps when there is a commit to branch testing. So that is the way you can actually do. So when you actually push based upon the branch, it will automatically push to the appropriate providers. So that is the way you can actually work. Okay, so that's what we have learned. Yeah, so just so we have covered almost everything. So domain name is also we can actually learn, but for that we need to have a Google domain account. You can actually try with Google domain account. So in the upcoming slides, there is a video for each and every step. So you can actually go through my recordings also, or you can actually go through this already pre-recorded recordings. You can also follow these recordings. So both are also mentioned. Both mention the same steps. You can always refer to these steps and follow and try it out yourself. I would encourage you all to actually do the entire cycle by your own. By this, you will be very confident and comfortable with how you can actually, what is the concept of circular continuous integration and deployment. You can practically implement it within 1 hour. So within 1 hour, you will be very comfortable with the CI/CD pipeline process. So this tutorial is very helpful. Just go through this and spend 1 hour of your time to do the entire steps. It should be very simple, straightforward. If you have any doubts, just ping me or just go through these recordings. It should be good. Okay. So there are many recordings. You can see these are all the recordings that we have. So go through these recordings one by one, and you should be good to learn about all the tools that I have explained to you right now. Okay. Yep. So let me take 10 minutes break, and I'll get back to you with next what I am going to explain. Okay. So let me get back to you in 10 minutes. So if you have any doubts, you can ask me afterwards. We can actually have a discussion. Hello. Okay. Hello, welcome back. My Zoom is hanged. I'm not able to. Can you? Am I audible to you?
Yeah, yes, Anil.
Okay. I somehow am not able to get my Zoom window, so that I can actually share my screen. Somehow I'm not able to see that. Okay, how to maximize it? Okay, I got it. Okay. Okay. So we have covered the basic, the entire workflow of Travis, right? So hope you go through the steps one by one. Probably you can start now only. And if you have any questions, just let me know. We can actually have a discussion. So we have covered the circular CI tool, Travis CA tool, and we have seen how we can actually do a deployment, right? How we can actually we can actually do a deployment of single Docker container. How we can do a single Docker container deployment to AWS service, right? What if we have multiple Dockers, right? So we have seen like multiple Dockers can be created and multiple volumes can be created using Docker compose.yml, right? So we have already seen that particular example. So here you already seen that we have something called Docker compose.xml. So, but it is everything we have seen the demo in our local machine. In the local machine, we have seen that we create a separate service called web, and we have created a separate volume. We have mounted a volume, and this is what we have seen as an example in our local machine. What if we have multiple Dockers and we want to deploy multiple Dockers in AWS Beanstalk? How we can do that? So we can do that also. So we have seen running example of how we can do a single Docker container, and similarly we can actually do deployment of multiple Docker container deployment in AWS Elastic Beanstalk. So there are small changes that we need to do. So in order to multiple Docker container, we have Docker compose.yml, right? Similarly, for Elastic Beanstalk deployment, we have a separate another JSON file that we need to create so that we can do a multi-container deployment. That is what we are going to see right now. Okay. And before that, I just wanted to mention one important thing. If you want to try it by yourself, if you create a Elastic Beanstalk after you are learning, make sure that you delete the Elastic Beanstalk application, because you will be unnecessarily be charged by AWS if you keep it on. So as soon as you do the as soon as you do your learning, when you have done with the basic learning of creating your application, make sure that your application you delete it. Otherwise, you will be charged. You will be billed. So I am deleting this particular application. I created this Elastic Beanstalk application as a demo to create a single Docker container application deployment, right? I deployed a single Docker container. So after the application, I have done my learning. I am just going to delete it. So go to actions and you just delete the application. And I had to confirm the application name. Okay, and delete it. So make sure that you delete the application, and also make sure that environment also gets terminated. I think it will get terminated after some time because the application is deleted. If it is not, go there and just delete it. Go there and just terminate it. I think it will terminate by sure. After some time, it will get terminated. Okay. Okay, this is what I had done. I had deleted my AWS Beanstalk application. Now, I want to deploy multiple containers. I want to deploy multiple containers in my AWS Elastic Beanstalk. So it is almost the same steps that you need to follow, but extra step that you need to do is that instead of using Docker file, you will be creating a separate file. So we have everything ready as a part of the course. You can download the source code from github.com. Go to that particular course and go to the multiple container deployment course, deploying multiple container flask. So this is what you can actually go. Before that, go to multiple container flask application. And we have already have a GitHub repository which has demo of how to do a multi-container deployment. So deploy multi-container deployment, this source code, you can actually go through this particular source code. So you can see that along with Docker file, in order to have a elastic beanstalk multi-container deployment, you need to create a separate JSON file. So this is what the JSON file is, docker run.aws.json. So this extra JSON file is exactly same, is almost like same like docker compose.yml. As docker compose.yml is used to deploy multiple dockers in a local machine, to deploy multiple container in AWS Elastic Beanstalk, you have to create a file called docker run AWS JSON. So you have to make changes here. So this is the example of how you make a multiple container deployment. So you have to create this particular file, and it is same like here. You have to follow the syntax of AWS Beanstalk in order to do a multi-file deployment. So by looking at it, you can easily understand. So here in this case, you have an array of environments. This first one is Postgres. So you are having 3 container deployment here. 3 container deployment. One is a simple Flask application that you are going to deploy, and second one is the Postgres DB deployment, and third one is Redis deployment. So you are going to do 3 deployments actually. So you have array of container definitions. You have an array. You can see this array tag here, right? Array tag. So this first JSON object is for one deployment, first container. This is for the first container, and this first container is basically for the Postgres DB. So you are going to create a Postgres DB container in this particular first object, and second object is another container. So this container is basically a Redis DB. You might be knowing about Redis, right? Redis is a in-memory cache database, in-memory cache database. So in this case, we are going to go use Redis database. So this is what a Redis container that you are going to create. And the third one is basically, sorry. Yeah, so this is the Redis image. This is Redis image with container parameter, this one, right? And third one is our basic web application. So this is the Redis web application. So this, you can see this by the name, right? So here you can see the name. The name of the application is Redis. Here you can see the name of the application is web. Here you can see the name of the application is DB. So essentially, this particular JSON says that we are going to have 3 containers which are mentioned in the container definition. In the container definition, you are having a DB container, and you are having a Redis container, and you are having a web application container. So this web application container will have the web application, and you say that this web application has dependencies with Redis container and DB container. You can mention it via the links, right? So this is what the JSON file looks like. And also along with it, we are also doing a mount. So you are going to mount, you are going to do a mount of Postgres data. So the Postgres DB has some Postgres data, right? So that also you are actually going to mount with the name Postgres data. So this is a simple example. We need to learn about, if you want to deploy multi-container application, we need to learn about how to do that using docker run aws.json, how to create docker run aws.json. So once you create this particular docker JSON, you are ready to go with the basic deployment, right? So you can actually look into the code here, into the code. This is a simple Python based Flask application. I hope because we have we had 2 sessions on Python, so we should be able to understand the basic Python. We have done a Flask-based Python application also, so we should be able to understand this particular code. So Python, it is a simple Flask-based application which contains different routes. One route is for the root path, and one is for save. This is save is actually when you actually save the form application. So just go through this particular code. Probably next week we will actually run this entire application and do a live demo of how to run this application and make it see that it is deploying to the AWS applications. Just we'll go through the code right now, and I will explain you what exactly this particular code does. As a homework, you can actually run this particular application end to end, and then you can actually see how you can run a single. What is the difference between how you can run a single container application, how you can run a multi-container application? You can actually learn by your own. By next week, actually, at start of the session, I'll start from here only. Okay. Now you have a multi-container application, and you actually you create this particular JSON, and you are good to go to deploy a multi-container application in your Elastic Beanstalk. And the difference that you need to mention, when you do a multi-container application deployment, is when you create a Elastic Beanstalk application. So you see that I have deleted all the applications, right? Cool. Now I will create a new application. But when you create a multi-container application, you need to make sure that you choose the platform as Docker, and here platform type. There should be multi-container platform. Not sure why it is not coming. Here you should be able to create a multi-container. Here you should be able to see a probably I will show you in the next session. Here you should be able to see the deployment platform branch type should be of multi-container, Docker multi-container type. So that you have to select actually. So once you select that particular type, multi-container type branch, then probably I did something wrong. Okay, I should be able to see the multi-container branch here. I will show you runtime demo in the next week. So for now, just keep in mind that you have to create a multi-container type application. Then you should be good to go. Okay. Okay, I will explain in the next session. So that is the difference between installing a single container application and multi-container application. So in multi-container application, you should be making sure that you are creating a JSON file which is understood by the Elastic Beanstalk, and you need to learn how should be able to create multiple container information in that particular JSON file. That JSON file, we have already gone through it. So once you are ready with the JSON file and the Docker Elastic Beanstalk application, once you create both of them, then the remaining steps are pretty straightforward. We have already gone through those steps of how to run a single container application. Similar steps we need to follow for deploying a multi-container application. Okay. Now I will actually dry run through the travis.yml. So here in the travis.yml, okay, travis.yml. Okay, so I will explain you another small thing. Yeah. So in Travis.ml, sometimes you might be interested in doing a Docker push after a successful build, right? So that you can do using this particular tag. So this is the area which helps you to deploying a Docker, building a Docker application in your machine and deploying it to Docker Hub. So by this command, you remember we already did executed this Docker push command, right? We executed this Docker push command from our terminal, and by doing the Docker push command, we were able to see that in our Docker Hub. So this we have seen a run demo of how the particular container image got pushed to Docker Hub repository, right? Same thing we can actually trigger instead of we manually triggering Docker push from the terminal. We can give the same command to travis.yml. So to travis.yml, we can give the same command, and using which travis.yml Travis.yml will actually push that particular image to our Docker Hub. So we can see this particular steps as a part of push. Whenever we do a git push, after the successful build, the Docker image will be created and it will be pushed to the Docker Hub. So this is required for our purpose because we are having a multi-container kind of deployment, right? So for that purpose, we are actually pushing it to Docker Hub, and AWS instance will pull it into its machine from the Docker Hub. So that way it will be helpful. So you can understand these three steps simply. So we know what Docker build does, right? So Docker build will actually build the image. Build the image with tag Anil Bhat and the application name, right? So it will build this particular image with this name. Once the build is done, you can actually do Docker login. So this particular second line does a Docker login to your account. So Docker login to your account can be done using these lines where you can understand this as you are echoing the Docker password, which is basically an environment variable. So you will create an environment variable called Docker password, and this Docker password we will give it in Travis options. Okay, in Travis options, here you have in Travis, go to options and settings, right? In settings, we will give the extra parameters. You can just say Docker ID and your name, all branches, and your account name, like this, and add. And you can say Docker password. You can give your Docker password as well, like Docker. Whatever. So this Docker password, everything you can actually give as an environment variable, which will be mentioned in the travis.yml. So in this travis.yml, we are using the variables Docker password and Docker ID. And Docker ID is the username and password is the Docker password. And using this, it will be able to successfully do a Docker login. After you are able to successfully log in to your Docker account, you can actually push the image to your Docker repository. So after these three commands will get executed whenever you do a git push. When you do any changes in your GitHub and then you do a git push, automatically these three changes will get triggered. These three commands will be getting triggered after a successful build, and it will be pushed to the Docker repository. Okay. So the Docker repository will be containing this build, like you have seen. Like this, you will be seeing a new entry with the name Anil Bhat B, my first app user. So user wish list app. Yeah. So you will see this repository that in your Docker Hub. After this getting pushed, you will be able to deploy a multi-container based application using these particular deploy commands. You have already seen these particular commands getting run, right? The same again, it will run successfully, and it will deploy your multi-container application into into the elastic beanstalk. So this is what will happen by running these instructions. Okay, so it will take this one, and along with that, it will take Docker run aws.json parameters, and it will deploy multiple containers, 3 containers. So it will take Postgres user, Postgres password, and these environment variables are supposed to be there in the Docker application, Docker Elastic Beans container application. So it is not Travis specific, it is specific to a replication. So when your application gets run, right, so it will be requiring the environment variables, Postgres user and the Postgres password and so on. So you are going to mention them here. Okay. So this is about how we can actually deploy multi-container deployment. You can actually run through the video session, which is already there in our course. You can actually go through this particular video session. Multi-container deployment, multi-container Flask deployment. Just go through this particular video session. Go through this. You can actually download the slides, and you can go through each and every divided video session one by one. So it contains each and every how the code is written. You will see the runtime of how the code is written. So there is a 1 hour session also. This small, including small sessions. If you want to learn the entire Flask application, how the Flask application built from scratch, right? So if you want to learn, so there is a about like 1.5 hour demo. You can actually go through that particular demo. So yeah, so this is the 2 hour session. So you can just go through the Flask, how the Flask Redis Postgres application is built from scratch. You just go through the session, 2 hour session, and you can learn the entire thing about this particular repo. This repo, how the repo is built, how the code is getting built. So what is this app, how this Flask application is getting built? You can just go through this. What is requirement.xml text? Basically, it is required for dependencies in Python application. So you just mention what are the dependencies you have in this particular Flask and in this particular file, and run the Python script, pip script, and it will download all the required Python libraries for it. Okay, so you can go through the video session, which is 2 hours video session, and learn how to build. If you are interested in building learn more about Flask application and how to connect to DB, a database, how to connect to Redis in the code, then you can just try run through this particular visualization. You will become expert in Python Flask application with Redis and database services. Okay, just go through it. We will go through. We will have a runtime of session of how to run this particular multi-container application in next session. But just spend some time to go through this all video sessions, and it should be useful for you. Okay, so this is session. This is all the session about how to push the code into GitHub. And as I already mentioned to you, also there will be a session for the JSON file that I have already mentioned. So this is Docker run aws.json that I have already mentioned. It is a small video session. I have explained the same thing, which is also explained here. Also, it is a 2 minutes session. You can just go through it again if you want to have a reference. Just go through this. And we should be good to understand about how to deploy a multi-container application in AWS, specifically AWS Beanstalk. Okay. Yep. Yep. So we are good to go. So let me know. Next session will start from where we have left today, and next session we'll probably try to cover other topics as well. We will start from what we have left today, and again go through other sessions like probably Jenkins or any other CI/CD tools. As time permits, we will try to learn more and more. So feel free to ask questions if you have anything for me. Otherwise, we will wind up for today. So put your hands on. So this is a very simple application. Like you learn about how to you learn about entire CI/CD pipeline, which is basically a core of the DevOps platform. So if you just do this, what we have learned today, if you just learn it right, so you should be becoming expert about. You should be feeling confident about CI/CD pipeline tool, basically Travis in this case. Tomorrow we will learn about Jenkins also. So before learning Jenkins, just put your hands on how to make a Travis configuration. Probably you can explore building a Travis application in Azure also, Azure application or Google App Engine. Maybe like if that may be extra learning for you. Just go through them. And by next week, I hope like you are all hands-on in all the code that was explained to you today. Okay. Yeah. So feel free if you have any questions, then we can discuss. Okay then. So let's wind up. So bye for today.